Happy Monday. I'm sorry I can't make it in today. However, we are going to do some math. Okay, we got some quick applications of quadrilaterals today. All right, let's get started. What I'd like you to do is take out your packets. Your packets are going to help you with a lot of these problems. The first shape we're going to talk about is the parallelogram. So let's flip to the parallelogram. Okay, this might be hard to see, so I just want to reemphasize the letters here. This is A, B, C, and D. Okay, one thing I do want to say though, all right, when naming or labeling a parallelogram, it's important to go either in counterclockwise or clockwise direction. You can't be random about it. So when I label this, okay, A, B, C, D, or I know it's already labeled for us, I have to go in one direction. Not the band, just the direction, like this. A, B, C, D, or I could have gone, just ignore the labeling for now, A, B, C, D. It's important that we understand you can't just be random. I can't go A, B, C, D like that. All right, you have to go in one direction. Think band, one direction, I guess. Let's start with angle BCD. So angle BCD is right here. They're giving us that is 125. We have to figure out the measure of BAD right there. Well, if you notice that those two angles are directly across from each other, meaning they are opposite angles. And looking at our packet, we know that both pairs of opposite angles are congruent. So angle BAD is also 125. All right. Just so you know, like every single part here is a separate problem. So if BCD is 125 for this part, it's not going to be 125 for the next part unless it says so. Okay. Next, let's look at AB. AB is 5x minus 3, and CD is 2x plus 3. Okay. Those are opposite sides. Looking at our packet, what do we know about both pairs of opposite sides in a in a parallelogram? The pause is for you to check, pause, check your packet. Oh, both pairs of opposite sides are congruent. So if the opposite sides are congruent, that means the sides are equal. So we set the equations equal to each other and solve for x. Math it up. Go ahead, if you want to work ahead, feel free to work ahead and check your work. I'm doing all this at once. I get 3x equals 12, so x equals 4. Are we done? Great question. No, we're not. We have to find A, B. So we got to plug it in. 5 times 4 minus 3. 20 minus 3 is 17. All right, let's keep going. Let's talk about this next one. So I got ABC is 50. Find the measure of BCD, which is right here. So I'm looking at these two angles. Are they opposites of each other? Are they opposite sides of our parallelogram? No, they're not opposite angles. Are they on the same side, or are they consecutive? Yes, these are consecutive angles, which means they have to be supplementary. So if ABC is 50, then BCD, I would do 180 minus 50 to get 130 degrees. Okay, we're going to practice these properties some more tomorrow as well. I'm not done. Okay, don't get too excited. I do want to say that since it is a Monday and I'm not there, we'll talk about our weekends tomorrow. I may or may not have some pictures for us. We'll see. Okay, given that ABCD is a rectangle, so I want you to flip to the rectangle page. You're given that AC, so A to C is one diagonal, and B to D is the other diagonal. Well, and it says find BD. All right, before we do that, we have to find X. Check in your notes, you know two things about diagonals. Those two things are that diagonals are congruent. All right, that those two things are diagonals are congruent. Okay. Also, you know the diagonals bisect each other. So if I look for something, if I'm talking about diagonals, sometimes I like to look at the labels on my packet and just translate that to my shape. So I think the labels are something like this: 3, 3, 3, 3. I think they're all 3 tick marks. I'm not entirely sure, but it's transfer those labels sometimes, and it helps me. Like I could have done that back with the parallelogram when we talked about the opposite sides. I said, oh, look, they have congruent tick marks. Okay, so I know that they're equal. All these entire diagonals are equal, so I can set my equations equal and solve. Add x, plus 30, which can be plus 60. So I get 5x equals 90. So x equals 18. And it wants me to find BD. Is going to be 30 minus 18, which is just 12. All right. Next one. Here we go. So I am given an expression for angle BAC. BAC. I'm going to do some erasing here of these lines just because I'll leave those tick marks on there for you. Where's BAC? Let me use my highlighter here. All right, so B to A to C is right there, and then C to A to D is right there. So I'm looking at this corner angle. Okay, well, we know our corner angles in a rectangle, the types of angles that we have there are right. So I know that if BAC is 4x plus 5, and CAD is 5x minus 14. And those angles together, and when we think about together, I think addition, have to make a right angle. That means they have to equal 90 degrees. They're not equal to each other, okay? Because in a rectangle, that says nothing about these angles, that angle being bisected. All right, and our next two shapes will have bisected angles, but not in a rectangle, okay? So I know that 9x, actually, why don't you just solve this one out? Find x here, pause, solve for x. I think you can do this. Check your work. I got x equals 11, and then we're not done. We have to plug it back into CAD, and you should get, I got 41, I think. 41. Yeah, 41. 5 times 11 is 55, minus 14 gives me 41. All right. Next thing, I'm looking at AE and CE. Oh, well, it's a good thing I have these marks here. Okay, if you didn't mark these, make sure you mark it to notice from your diagram in your packet. All right, so it's a good thing I have those marks, so I know that AE and CE are the same. It means they're equal, they're congruent, so I have to set them equal to each other, and then I just solve it out. If you math this up, right now we're doing with a lot of linear equations. We will eventually make these quadratic. You do get x equals 3. Okay, but it asks you to find AC. Okay, AC is this entire segment, right? I'm going to delete this highlighted stuff. AC is this entire segment here, the entire diagonal. But I only have an equation for each piece. So I can do this two different ways. All right, I can plug x into both and just add it together. Or you can plug x into one of them and then just multiply it by 2. So I could plug x into 2x plus 3. 2 times 3 is 6. 6 plus 3 is 9. 9 times 2 gives me 18. Or I could plug it into both, and you'll still get 18. Okay, that's a Q. Wow. Let's see. I'm going to pause it, and then I'm going to make another one. All right, let's just keep going. Forget it. No, I'll pause it.